Ladies and gentlemen, welcome back to your cybersecurity series. My name is Vlad and I'm here to help you and support you in your cybersecurity journey, even if perhaps you don't have a technical background. Today, this is episode 28, and we are continuing our series on cryptography. And by now, it's finally time that we introduce the two main characters of cryptography, and those names are Alice and Bob, so A and B. And you will see that Alice and Bob, if you're interested in cryptography, they are always mentioned in the exercises, the examples, the theory, even in some demonstrations. Basically, those are always the two names that are taken by the researchers. So, of course, it's kind of a community joke. Everything is about Alice and Bob. Those two people are often in love or depicted as being close friends, and they want to share some secret messages, and they don't want any other recipient or any other spy to know about what they are talking about. You can think of them as secret agents, so to speak. And often, the external party that is trying to breach into their correspondence is called Eve, which is why here in this short cartoon, I'm describing those three characters together. So, jumping in the content of the day, what we talked about in the previous episodes is really symmetric encryption. So, if you go back to episode 26, we introduced the concept of the exclusive OR, so XOR operation, which is something that is built into your modern laptop, into your modern processor, and it's extremely fast. The idea is that you will be able to encrypt and decrypt by using the same key, just like it's depicted here on the graph. And in the previous episode, episode 27, we also talked about how today it's difficult because you cannot really perform what we call stream cipher, meaning encrypt a long file. Otherwise, you would need a key that would be the same length, which is why we slice our message into several chunks and we encrypt them one by one. And we talked about block cipher, which is this principle of encrypting by blocks. And there were different algorithms: DES, which is deprecated, AES, which is the modern way. But altogether, those are just illustrations of the same principle, which is symmetric encryption. And as I said, there are great advantages. First of all, the speed, it's extremely fast. And since it's fast, you can use it on, let's say, bigger or large files, volumes, partitions, even drives. So you can encrypt pretty much anything, but it's often used as a or in circumstances where you are working on your own. So, for example, you are going to encrypt your files on your desktop, or just an archive, a zip archive, or even something that is perhaps on your cloud, but you are always the one having the key and you are encrypting your own files. When you want to work with someone and if you want to exchange certain files that would be encrypted, you understand that at some point you have to share the key, and that would be a main limitation of this symmetric encryption. Because as we said back into the previous videos about the Kirchhoff's principle, we said that the secret is not on the algorithm. It has nothing to do with the different parameters or the surrounding elements. All the secret in cryptography lies on the cryptographic key, meaning that if the key falls into the wrong hands, then the correspondence can be breached. And that key here in this example where we have Alice and Bob, of course, the key is vulnerable to interception. And we don't want Eve to read the correspondence between the two lovers. So how can you encrypt those correspondence? You will have to come up with a different kind of encryption, and that's the topic of the day. That's what we will call asymmetric encryption. Just for reference, previously, a few years ago, many years ago, in the 80s or 90s, the administrators, when they were configuring a symmetric encryption key, they would have to type manually the encryption key that is sometimes more than 30 characters long. They would have to type it manually in the first terminal, and then they would have to type it again in the second terminal. Because if you do just copy paste, of course, you are transmitting at some point on the network your encryption key. So they will have to write it down on a post-it note and copy it. And you can see that this is not something really scalable. If today you have some laptops in Paris, some laptops in New York, you need to find a right way of sharing this encryption key. So anyway, the researchers, they thought about it and they invented a different kind of encryption, which is called asymmetric encryption. The idea is that instead of having a single encryption key, here we have a couple of keys. They are part of the same object, they really work together. We will have a public key depicted here in green, and this public key will be shared basically with everyone. So any recipient, any partner, any subcontractor, supplier, customer will be able to see your public key, and they will use it to encrypt correspondence that is addressed to you. And since you will be the only one having the blue key, so the secret key, you will be able to decrypt the correspondence addressed to you. Again, those keys, they really work together. The blue secret key can only decrypt elements that have been encrypted with the corresponding green public key. So you cannot, I mean, you see them, you generate them in pairs, and they really work in pairs. I hope, yeah, I have other graphs later down in this video, so hopefully everything will make sense by the end of it. If not, don't hesitate to, again, ask some questions in the chat, and I will do my best to answer all of them. So how can you generate those pairs of keys? Actually, there are different methods. There are different algorithms that allow you to generate a couple of cryptographic objects, so to speak. The most known one today is RSA. RSA actually comes from the names of the three inventors, Rivest, Shamir, and Adelman. It's the most commonly used, but there are other methods. I'm not going to go in depth of how it's being done because that relies on complex, and when I say complex, I mean extremely complex mathematical algorithms. Some of them are using elliptic curve, sorry. Some of them are using prime numbers, which is why all the researchers about prime numbers are extremely important in IT because they have direct implications and applications into cryptography. If you are curious, nevertheless, here is basically the principles of RSA. You can just pause the video and have a look. The idea is essentially to select two prime numbers that would be extremely big. So not, I mean, when I say extremely big, I'm saying billions and billions and billions. So something with perhaps 40 to 50 different numbers within, digits within the number. So you find those two big prime numbers, you are going to multiply them, you are going to calculate the Euler function, which is the phi of n, and etc. etc. You end up by finding two numbers that combined to each other will be your private and public key. So if you have advanced maths, that will be right, let's say, accessible to you. If not, don't worry about it. The idea is that you will manage to get a public key and a private key that are really working together. So that's our assumption. If you're not too much into math, forget about the rest. Anyway, so once we have our encryption keys, this is how they work. So first we have Bob, and Bob wants to say, hello, Alice. What he's going to do, as I said, he's going to use Alice's public key in order to encrypt his message. And once Alice receives the message, which is encrypted, she's going to use her own private key to decrypt. So as you can see, it's really about using the same couple of keys. So we are using Alice's public key to encrypt and Alice's private key to decrypt. If you are using Bob's key first and then Alice's key as a second, it's not going to work. You are not going to be able to recover properly the message. Having said that, as you can see, it's extremely important that you acknowledge that the private key has to remain private. What you are going to share with all of your potential correspondence will only be the public elements. So in terms of advantages, first of all, it can be changed and regenerated by each party freely. So as opposed to our symmetric encryption, imagine that you have a huge network of 100 people within the same community. If you were to have a same symmetric key for everyone, the compromise of a single endpoint, a single person, would imply the compromise of basically the entire network. And then you would have to regenerate a symmetric key for everyone, retype it on every terminal. That would be a mess. Here we are really considering that each endpoint has its own identity, its own set of keys, and that can be regenerated freely by everyone. It's easy to communicate because you will basically put your public key on, for example, on a web page, on on any type of open or public facing website. You can also have that as part of an Active Directory or any type of LDAP annuary in IT. Sorry, I'm getting a bit too technical here, but basically, you can advertise your public key to pretty much anyone, either on your corporate network or even on the external world with a website. And this ensures that only the intended recipients, so only people that are writing to me with my public key, I will be the only one being able to read their message because I'm the only holder of the private key. Of course, there are limitations. First of all, and that's something you need to know, it's extremely slow to encrypt content using that method. And it's also slow to generate a new pair of keys, which is why we do not use asymmetric encryption to encrypt large files because it would take minutes or hours. Which is why really what we can do instead is using asymmetric encryption to compensate the limitations of symmetric encryption. So what we are going to do is encrypt the symmetric key, and with the symmetric key, we are going to encrypt the content, which is why we will talk now about a session key. The session key will be the symmetric encryption key used, for example, in between Alice and Bob, or between you and the server that you want to communicate with. And there is a protocol, a PGP, it's widely known. So PGP stands for Pretty Good Privacy. It's also a statement, so to speak, but that's the name of the protocol. The idea is that it really mixes symmetric and asymmetric keys, and it's pretty much standard. I mean, that's the greatest example you would come across because it really illustrates how it's being used. So first of all, let's say you want to send a message, so a PGP. Yeah, I didn't mention it, but PGP is for emails. The idea is that you are going to generate first a symmetric encryption key. And you also have your plain text message, so let's say the content of your email. With this session key that is symmetric, you are going to encrypt your plain text message, meaning that you are getting encrypted data. And then this session key, you are going to encrypt it as well with your recipient's public key. So the recipient's public key is an asymmetric key. You put all of that together and you get your encrypted message. All is well, you send that to your recipient. What the recipient gets is, of course, the encrypted message, and he will, first of all, divide the two elements. So you have, of course, the encrypted data and you have the encrypted session key. The first thing to do is decrypt the session key. So he's going to use his own private key to do that. And then once he finally recovers the session key, he will be able to read the content and get back the plain text message. So that's really an illustration of how you can benefit from both sides. First of all, you have the speed and the ability to encrypt big files or big content with a symmetric key, and then you are using the asymmetric key to encrypt the session key. I'm sorry if that's a lot of keys, but basically that's the main principles, and that's why basically if you understand this slide, you have understood almost 80% of cryptography today, which is why I'm quite stressing on it. But that illustrates really both methods, both principles. If you want to push it even further, I have a, let's say, more advanced example in the slide right afterwards. But if you really manage to get that, then, first of all, congrats, because now you have really all the bases that are necessary to understand cryptography. There will be, of course, a few other videos about signatures and how to further, let's say, use cryptographic elements. But now, in terms of confidentiality and how to use different keys, you have really the principles to understand all the advanced and modern algorithms. So the advanced example of the day, it's going to be Kerberos. So Kerberos is an authentication protocol. It's a set of principles as well, and I'm going to use that to demonstrate how asymmetric and symmetric encryption keys can be used together. But first, we need to describe a bit what you see here in the video. So first of all, you are the client, so you are on the top left. You have your own private key, which is depicted here in green. And the idea is that you want to reach out to a certain service. You want to reach out, for example, to a web server or a SQL server. Basically, you want to access a certain application within your company. And on the right side, we have the company infrastructure. So the company has three different layers of servers. If we start at the bottom, we have the famous service server. So the one that we want to access, it's at the bottom right with a symmetric key in black KS. And Kerberos actually comes from with the two layers that you see at the top on the top right corner. First, we have an authentication server, and then we have a secret granting server. So the idea is really to create those two additional layers to protect the company, and you will see why. First, the authentication server knows all of the clients. So if you are within a company, the authentication server knows all the individuals, all the endpoints. So of course, the authentication server has your public key. So written here as KC, yeah, that's the green key. And the authentication server knows, of course, the secret granting server. So they have shared between each other a symmetric encryption key that is called KTGS. So it's the one here in yellow. So that is shared. It's a shared secret. The admins have to, again, type it perhaps manually. So they have put the yellow key within the authentication server, and they also typed it in within the ticket granting server. So how does it work together? Oh yes, sorry, last precision. So if the authentication server knows all the clients, the secret granting server doesn't know the client. He only knows the different servers, which is why the secret granting servers has a series of black keys. So here, for example, key S, the one that is for our specific server, a service server that we want to access, like a web server, as I said. But you have to understand that if there are multiple applications, they would have, of course, multiple keys. So it's really a different principle. The authentication server knows the client, the secret granting server knows all the applications. All right, so how do we access the server at the bottom right? So first of all, we are going to authenticate with the authentication server. Of course, as the name implies, it is an authentication server, so it knows all the client. So we are going to, for example, type in our password. We are authenticated. We are on the corporate network. Great. Then we are going to say, well, I want to access the server. Please help me get through it. What you are going to receive back from the authentication server is actually a combination of two messages. The authentication server is going to generate a red session key. So it's a session key to be used between you as a client and the secret granting server. It's really a session key that is generated on the spot for you to be able to communicate directly with the ticket granting server, because here we imply that we do not trust the other agents on the network, which will ensure that the confidentiality of your communications only between you as a client and the secret granting server. If you look at the schema on the first row, this red session key is sent twice. First, encrypted with your public key, so the green key, and also encrypted with a yellow key. So once you receive that, of course, since you have your own private green key, you are able to open the second message. You get back the session key. But as you can see, the message here that is highlighted in orange, this is not something that you can decrypt because you do not have the yellow key. So the first thing that you need to do afterwards is reach out to the ticket granting server, and you are going to take this orange message and send it back to the secret granting server. Why? Because it was encrypted with this famous yellow key, so the KTGS, and only the secret granting server is going to be able to decrypt it manually. So after this first step, which we call the client service authorization, the secret granting server is being able to finally recover the red key. So at this stage, you as a client, you have the red key. The secret granting server as a destination also has the red key, which means that you can talk to each other. And of course, you can do these steps again because the secret granting server will do the same thing. He will generate a session key in blue. This session key will be specific between you as a client and the service server that you want to reach out to. The blue key is going to be encrypted again twice. It's going to be encrypted in the first message with a black key that you do not have, so you won't be able to read it. And it's also going to be encrypted with the red key which you add from the start. So once you receive this pack of two messages, first you use your red session key, so you get the blue key, and you are going to send back this message highlighted in orange that you cannot read, but the idea is that the service server will be able to decrypt it with its black key. So again, using the same principles, we are in a situation where you as a client finally have a blue session key to be able to discuss with the service server, and the service server is going to receive the blue session key as well once they decrypt it with the black key. You will so it's can look a bit complex, but it's really the idea of having a three-tier infrastructure, an authentication server who knows all the clients, so he is managing the green keys. You have a ticket granting server who is able to generate session keys for you, and you have service server who will give you access to whatever you need. You can also look, if you really want to get into the detail of the graph, that every time we are sharing a key, but we are also sharing the identity of our client. It's important for certain accesses. The address, of course, and the validity, meaning that those session keys, so the red and the blue session keys that were generated, they have an expiration date. So your communication cannot, even if this key gets compromised somehow, they are going to expire at some point and they will need to be renewed. Again, since they are session keys, they are quite easy to regenerate, which is why we are using symmetric key for that. So that's another example of how you can mix session keys, which are symmetric encryption keys, and asymmetric encryption keys, like here in green, if the client has his own secret key, secret green key, and the authentication server has your public key. So, in the context of, for example, hiring a new person, you will have a new client, so a new endpoint. This endpoint can generate his own set of asymmetric keys. It will register the public key within the authentication server, but they will keep their own private key for themselves. So, as you can see, it's really scalable. If you need to have more and more clients, it's easy to do. And same thing, if you need to configure a new service server, you can easily register them within the ticket granting server. So it's really practical, and it's being used in a network where you really don't trust what's going around, and you are making sure that all communications are properly encrypted in between the different endpoints. I know it's a bit complex, but I hope you follow the reasoning. Don't hesitate if it's to replay this video or again ask me some questions. I would be happy to answer that. Having said that, so that was all for the asymmetric encryption. Next video, we'll talk about the signatures, because something that we have covered so far is only about, and I will go back to my very first slide. Everything that we talked so far is really about the confidentiality of the correspondence. But as you can see, we do not have a proof that the person who sent the message is really who they pretend to be. So here in between Alice and Bob, we make sure that only Bob or only Alice is able to recover the message thanks to their own secret key. However, there is no proof that the person who sent it is really who they pretend to be, because anyone could use your public key. So, what kind of proof do you have that it's really Alice or it's really Bob? But that's for the next video. I hope you enjoyed. Thank you for your time, and see you soon.